Okay, guys. Lesson 6, are we there? Lesson 6 is a lot of function review for one. Functions, their equations, graphs, functional notation, domain, range, a little bit about everything there. We are going to, if you happen to have your graphing calculator in here, there is one thing I'm going to do on the graphing calculator. I think just one. But let's get moving. So, function. You guys remember anything about functions? Okay. So, to decide if something is a function, one thing to do is to look at the vertical line test. If we draw that vertical line, it only crosses the function one time, okay, at most. Okay. If you're looking at a list of like ordered pairs or something like that, each x value maps exactly to one y value, right? So, wording here is any equation in which every individual x value, or in other words, domain value, maps to only one y value or range value. So there's also a reminder that domain is x, range is y. Old news, right? Okay. So, don't forget, domain, x, range y. One thing, and I think you see it a little bit, I think there's an example in the homework if I recall, I could be mistaken, talking about a function machine, and just kind of a visual of functions that each input goes in and has an output, right? So, for example, if you have the function f of x equals 4x, if the input is 2x, so in other words, if your domain value is 2, I think I said 2x instead of 2, didn't I? If the domain or input is 2, then that means your output or your range is 4, because the machine is telling you to do 4 times the input, right? And that's just kind of a visual there. Now, our example 1, again, just reviews function. Given f of x equals x squared plus 5. Find, and there's 3 parts here. A is f of negative 2, B is f of x plus 2, and C is f of x plus delta x. Okay, so let's try A. If A asks us to find f of negative 2, what's the idea? How do functions work like this? Right. Every place you see an x, we're going to replace it in this problem with negative 2. So instead of x squared plus 5, I'm going to say negative 2 squared plus 5. Negative 2 squared is 4. 4 plus 5 is 9. I would venture to say you've been doing that since middle school math. Okay, B. F of x plus 2. This time, every place I see an x, I'm going to replace it with what? X plus 2. Whatever that quantity is in there. Every place I see an x, I'm replacing with x plus 2. So my original equation is x squared plus 5. So instead of x squared, what am I replacing that x with? X plus 2. So x plus 2, quantity squared, and then plus 5. Are we okay with that? Now, depending on the situation, you could possibly leave it like this, or, let's practice for a moment, how can we go another step and simplify? Close, but not quite. Okay, so Daryl got the common mistake out of the way for us. If he said, oh, just square, and it's x squared plus 2 squared, so x squared plus 4, and then the plus 5. But this isn't x squared plus 4. You have to FOIL. Can we FOIL that in our heads? X plus 2 times x plus 2 becomes x squared, right? And then what are my insides and outsides? What? 4x, right? Because you've got 2x and 2x, so plus 4x. And then you would have a plus 4. If you want, there's also a plus 5, which makes it a plus 9. Can we handle that? I'll do the mental math with you if you'll let me. Just tell me when I go too mental on you. Okay. Now, this function notation, guys, this is another lead-in, okay? They're leading us in for when we start talking about derivatives, okay, which is a little ways down the road, but they're leading us in. When it asks us to do this f of x plus delta x, first of all, you're familiar with that triangle being delta? That's a physics and or chemistry thing, right? Okay. So that when we get to definition of derivative, that will be a huge thing, being able to do something like this. So let's practice now. Every place we see an x, we're going to replace it with x plus delta x, right? So instead of x squared, it's going to be x plus delta x squared. And still plus 5. Okay. How do I multiply this out? So we're going to practice multiplying it out while we're here. We need to what? FOIL again. Okay. So first, x times x is x squared. I'll go ahead and say plus because we're all positives here. Outsides, there'd be an x times a delta x, right? So x times delta x. What about the insides? Another x times delta x. Do I need to write this out on the board? Or can we visualize it? Now, what's 1x x times delta x plus another x times delta x? 2x delta x. So I'm going to write this as 2x delta x. I put that delta x in parentheses just because that delta there, what does that delta go with? Plus, what's last then for the foiling? Okay, delta x times delta x, which is the quantity delta x squared. Officially, I wrote it with parentheses because, again, you want to make sure it's that whole delta x squared. And then don't forget, what else do I still need to include? Plus 5. Does anything clean up more than that? Unfortunately, no. Okay. Moving along, if you'll allow me to. Example 2. Now, it suggests, technically you can use any calculator, but we're going to practice something with the graphing calculator. Use the graphing calculator to estimate these values, f of pi, f of square root of 2, and f of cosine 5 square root of 3, where f of x is 1 over the square root of 1 plus x squared. Now, one option here. Can you just plug each of these in and do it that way? Yes. And there's nothing wrong with that at all. Okay? Plug it in, do it, you've got it. I'm going to show you a different way, though, that where we do something once and it would kind of work for all of them. In that, do you guys remember how to graph? Graph this equation. Again, I'm not against you guys just plugging them in individually. Did we all bring our calculators today? Okay. Remember where to find your fraction? If you do a fraction, the shortcut is alpha F1. So I'm going to do 1 over second square root 1 plus x being that xt theta n value. Then I can use my squared button on the left if I want. Are we there? I know it's been a while. We just like I had to do something on my graphing calculator to teach pre-calc this morning for the first time, and I struggled with a few things, like where to find the fraction shortcut, things that once I start using them again, I know, but okay. Maybe do a Zoom 6 to graph that, depending on what you last graphed. Does yours look like mine? Okay. Huh? Yours doesn't look like mine, but you're going to make it look like mine? Okay. Sounds good. I get it. You know, it's...
The way they have that fraction board, like, sticking out over this very look like a negative.
Oh, no negatives there.
So mine was upside down.
Ah, okay. Yep. You got it. Okay, so now, A asked me to find f of pi, yes? So that's really, you guys know, pi is the x value. You're plugging it in there. There are a couple of different ways to find what the y value, because what we're basically trying to find is what the y value is at pi. Official, you remember our trace menu up here? Where if you do alpha and the trace, no, not alpha, second. Again, I'm rusty. Second, trace, and you get that calc menu where you can do your zeros and your min, maxes, intercepts. Number 1 is value. If you go there, notice down at the bottom it says x equals. What is my x value right now? Pi. So if I put in pi, not 3.14, but actual pi, and I hit equals, notice it takes my cursor there, and what does it tell me? There is a y coordinate there, yes? So when x is 3.14, so on and so forth, y is 0.3033. That is one way to do this. Now, the advantage is because I have to find multiple x values at this point, I don't have to retype it into my equation. I just redo that process. B asked me to do f of what? Square root of 2. So, another way I can do this is instead of going into the trace menu and getting value, if I just hit trace, does it matter if something was already there? I don't think so. If I just hit trace and then I type in square root of 2, like if you hit trace first and then start typing, it will pop it up and type it in as an x value. And so then you don't even have to go into that calc menu. And again, notice I hit square root of 2, and what's it doing? Tells me x is 1.414, which there's your square root of 2, and what's my y value? 0.5774, or 0.577. Are we okay with that? Okay, so I'm going to write it over here. My options, I can do trace, and what I just did that time is then after I hit the trace button, I just entered the x value, or the other option is I can do trace and second calc. I didn't really write that right, and just go to the value, okay, and go to the value option. You guys ready for C? Sorry, it's regraphing mine. So C is f of cosine of 5 square root of 3. So, I'm in my graph, I can just hit trace, and then what is the x value I'm going to type in? I'm going to type in cosine 5 square root of 3. I'm going to hit enter, and it gives me this. It tells me my x value is negative 0.72 0.8217, and my corresponding y value is 0.8109. Did everyone get that value? Why might not you guys have gotten that value that I got?
We're in degrees and not radians.
You need to be in radians. Why do we need to be in radians? Yeah. It says cosine of 5 square root of 3, by default, automatically go to radians unless there's something indicating degrees. So go to mode, change your mode over, go back to your graph, redo. In calc, you will often want to be in radians. Now, are you guys in physics also? Okay. It's going to be a big challenge this year. You're going to have to go back and forth because physics, you usually need to be in degrees. Calc, you're usually going to need to be in radians. So you're going to constantly have to be checking, what am I in? What did I last use my calculator for? Now, did we get the correct answer? Sorry, was that mean of me to not tell you ahead of time? But it's so fun, and it makes, here's my thing. It makes you stop and think, right? That's what I'm trying to do, whether you like me for it or not. Okay, example 3. If you're okay for me, go on. Use the graphing calculator to find F1 problem 10 times on my calculator. Yes. Could I graph it and plug in 10 values on my calculator? Yes. Okay. Third option. And it's refreshing calculator skills here. I don't know if you remember using our list last year. We're going to use list. So, if you would, you need to go to Stat. Remember, you have a Stat button, and you're going to go to Edit. So, Stat is right here, and then go ahead and hit Enter for Edit. Now, if you're like me, you have some random stuff in your list. No idea what this is last from. How do you clear a list without deleting the list? If you just want to clear the list out, clear the numbers out, go up to the heading. We're not deleting the list because that will delete my whole column of L2s. I'm going to hit Clear and then Enter, and that will clear my column of entries. Same thing at L1. I can go to that heading, I can hit Clear and Enter, and that clears all the numbers out of it. If I hit Delete, you've now deleted that column, and there's a way to get it back, but I don't remember how right off the top of my head. Okay? You don't have to reset the calculator. You could, I'm sure. Okay, so L1 is my inputs. What are my inputs? 1 through 10. So in L1, arrow down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just writing these down on the paper. So L1 is your input, your X's. That makes L2 my outputs. How do I get L2? We're plugging our numbers into what? This right here, yes? So this equation becomes my L2. Do you remember how you go up into the heading? So you're at L2 and it says L2 equals. We're going to type that equation in. So I'm going to do a fraction. I'm going to do 1 over the square root of 1 plus. Now, my equation says x squared. Where are my x's? My x's are in L1. I don't know where your x's are, but so now instead of saying 1 plus x squared, I'm going to say 1 plus L1 squared. L1 is the second function of number 1. And so now mine says 1 plus the square root of 1 plus L1 squared. You hit equals, and what happens? I just got all 10 answers. If you know how to do that, it's quicker. Now, if we have to walk it through baby steps like this, it's not any quicker, is it? It would have been just quicker to do it 10 different times. But your answers should be matching with my answers. So in order to do L2, I did 1 over the square root of 1 plus L1 squared. And so when x is 1, y is 0.7071. When x is 2, y is 0.4472. When x is 3, 0.3162. When x is 4, 0.2425. When x is 5, 0.1961. Okay, at 6, it's what? 0.1644. At 7, 0.1414. At 8, 0.1240 if you want. At 9, 0.1104. And at 10, 0.0995. Again, a way you can use your calculator, right? Okay, get those, and I'm ready to go on to functions whenever you guys are ready. You guys ready? Okay. Example 4. Which of the following are not graphs of functions? So which are not functions?
Second and fourth.
Okay. Vincent says the second. Oh, I didn't ask why. I just drew in. How do we know this? Vertical line test, right? And so right there where I drew that in, that touched 3 times. So the second one's definitely not. He says the fourth one, because if I draw straight through one of those vertical line snippets, that's not. Okay, so second and fourth, definitely. The first one, you're okay with that being a function, right? No question there. What about the third one?
That's one of them open, it doesn't include the value, so
Okay, there are 2 dots lined up. If they were both filled in, we'd have to say not a function. But since one of them was an open dot, one of them was a closed dot, it is a function. So the ones that were not functions failed the vertical line test. The easiest way to test for function. Okay, example 5. Which of the following sets of points could lie on the graph of a function? So I was thinking there's maybe a typo I needed to fix here, but I guess not. Okay, so I'd say go through and analyze each one individually. Can A be a function? Yes, because each x value is different, right? And remember, it's each x value pairs with one and only one y value. So if each x value is different, automatically, it's good. It's a function. And this does say could lie on the graph of a function. Oh, there is a typo. Okay. If you look at B right now, it's the exact same set of points, isn't it? Let's make that 3 and 3, 4 a 1, if you would, please. Knew there was a typo in this problem, I just couldn't see it. So, based on a typo, if my points are now 1, 2, 2, 3, 1, 4, and 4, 5, is this a function? No? Why not?
Because 1 is paired, 1 as an x value is paired with both 2 and 4.
Okay. 1 is paired with both 2 and 4 as y values. So you would have a point at 1, 2 and 1, 4. Those are on the same vertical line. Fails the vertical line test. Okay? C? Is C a function? What's the catch here? Yeah. I mean, if you're looking at do my x's repeat, well, it does look like my x's repeat. 4 repeats, yes, but what's the catch? 4 repeats with 3 repeats. So it's 4, 3, and 4, 3. If I graph 4, 3, and 4, 3, can you tell that I graphed 2 4, 3s? No, they're the same dot, aren't they? And so this one is still a function. And D? D is a function, right? All my x values are different. So the catch here is that we needed the domain, in other words, the x values cannot repeat. So if you want to write yourself a little note about how we determined function versus not function, it's because the domain cannot repeat. Again, that's like Algebra 1 stuff, right? It's just a matter of pulling it out of the Algebra 1 portion of your brain that is buried. Ready for the back? Okay, example 6. Determine whether the following statement is true or false and justify your answer. The mapping of f of x onto x to the fourth plus x squared is not a function because it maps both 1 and negative 1 to positive 2. Do you understand the math talk there? Because that's the big battle of this question, is the math talk. What are they claiming here? If it says it maps both 1 and negative 1 to 2, what are they saying are ordered pairs here?
1, 2, negative.
Okay, so they are claiming, if you would, that when you put in a 1, what do you get out? A 2. So they're saying that f of 1 is equal to 2. Or in other words, the ordered pair, 1, 2. What else are they claiming? That when you put in negative 1, you also get 2. And so that is the ordered pair, negative 1, 2. Now, first of all, are those statements true? If I put in 1, 1 plus 1 becomes 2. If I put in negative 1, a negative 1 raised to an even power becomes 1. 1 plus 1 is 2. So those are true statements there. What was their claim? That this is not a function. Agree, disagree? True, false? Are these points a function? Yeah. The y values can repeat, that's fine. The x values have to be unique. So this is good. This is a function. And so the key here is that two different x values can be mapped to the same y value. So I'm going to say a big old false. And my explanation is what I just said. Two different x values can be mapped to the same y value. Sometimes the hardest part of calculus is getting past all the math talk. I mean, that's, you have to learn to look for words, dig in, and analyze. Okay, example 7. Determine whether the following statement is true or false and explain your answer. The equation y equals 1/2 x squared plus 2 is not the equation of a function because there is a vertical line that intersects the graph of this equation at more than one point. So, with that in mind, they're talking about vertical line tests. So what are they trying to get us to visualize? Yeah. What does that graph look like? Now, yes, you have a graphing calculator. Yes, you can plug this into a graphing calculator. But there's something to be said for calculus at this point where it doesn't have to be precise, but can you visualize an idea of what that graph looks like? What do you know about y equals x squared? Parabola. What's a plus 2 do to a parabola? Shifts it up 2. What's a 1/2 do in front of that x squared? Actually, it wouldn't be a stretch, it would be a shrink. Which, what happens with a shrink is that it makes it wider. Okay? So it is going to stretch it horizontally, but it's shrinking it vertically. But, whether it stretches or shrinks, okay, you know there's a stretch or a shrink. Is that going to affect the vertical line test? No. Okay, so I know visually I've got a parabola that moves up 2. It's still a parabola. What do you know about basic parabolas? Are they functions? Yeah. And so there's something to be said for your half of the AP test where you're not allowed to use a calculator for being able to visualize that graph. Remember in pre-cal I made you, I was like, okay, you need to know these graphs. This is exactly why. So, about the answer, right? True or false? Yeah. This says this is not a function. Well, false. Oh my gosh, I just wrote falses. Is false is such a thing? Okay, the graph passes the vertical line test is my explanation. Okay, domain and range. We may not have much time for homework, but we should at least get through the notes, I hope. Unfortunately, that happens some days. Find the domain and range of the function f of x equals square root of x plus 5. Okay, let's talk domain. Domain is all about our x values. Okay, as you think about this, this is the graph of a square root. What do you know about a square root? Okay, you can't have a negative under the square root, correct? So that means in this case, if this is the square root of x plus 5, whatever's under the square root has to be positive, yes? If it can't be negative, it has to be positive. Positive is what in terms of inequalities? If something is positive, it has to be bigger than 0. So what I'm going to do here, and again, it's not that we couldn't think about this graphically, but I'm going to take whatever's under my radical, x plus 5, and set it greater than or equal to 0. Because it could be equal to 0 or it could be bigger than 0. But it cannot be smaller than 0. Can you solve this for x? Subtract 5 and x is greater than or equal to negative 5. That means the only x values that work in this equation are numbers that are bigger equal to or larger than -5. Now, I don't want you guys to freak out at how the answer key would write this tomorrow. Okay? This calc book uses something called set notation. Okay? So, one of those squiggly things, right? X is a member of the reals such that X is greater than or equal to -5. Okay, so the squiggly braces indicates the set notation. This right here says X is a member of the reals. And what that is it's kind of like a C with a little line inside of it. And that's just saying that this X value is a member of the reals. Remember we use that fancy R for reals? That vertical line you read as such that. So X is a member of the set of real numbers such that X must be greater than or equal to -5. Now, do you still have the answer X greater than or equal to -5 in there? Yes. Just trying to show you set notation. Now, am I thinking you're going to see set notation on AP Calc tests? I don't know that I've ever seen anything. But again, upper math classes, it's good to be familiar with this type of notation. I would say give it a try for homework. You know. Now, that was domain. Domain is your X values, your inputs, right? Range is your Y values, your outputs. What kind of outputs can I get here? If this whole function is a square root, what are the only type of answers that I'm going to get? Real numbers that are what? Greater than or equal to 0. In other words, remember this earlier? The idea is the square root of x plus 5. That right there has to be positive, right? Greater than or equal to 0. But we're talking range. The square root of x plus 5 is equivalent to f of x, which is another name for y. So this equation has to be greater than or equal to 0. So since that whole equation has to be greater than or equal to 0, then that means we're saying y has to be greater than or equal to 0. Because you're only going to get positive outputs. Not in an equation setting, if they give you a radical, that only indicates a positive. They would have to put a negative sign in front of it if they wanted the negative root. Okay? Yeah, if it was like y squared equals, yeah, you'd have to solve it. Then you could, yes. Okay, set notation. This time, we're talking range. Instead of saying x is a member of the reals, y is a member of the reals, such that y is greater than or equal to 0. Now, for proof, I'm all about trying to get you guys to think analytically. That's why I'm looking at the equations. Do my answers make sense with my graph? We said x has to be bigger than -5. Well, where's my graph end right here at? -5. There's nothing to the left of -5. Are there x values all to the right of -5? Yes. We said y has to be greater than or equal to 0. So vertically, is there anything below 0? No, my whole graph is above the y-axis, so it's above 0. Does that kind of make sense there? It's just trying to put it all together. Did I just do example 9 because I didn't read ahead to see what example 9 was?
Yeah.
I did. Okay. Hey, that's good. Number 9 is use the graphing calculator to verify the domain of f in example 6.8. Okay. Now, the one thing I have written in my notes, use the graph and the trace feature. How does the trace feature helps me? Well, I can hit trace and I can arrow over and I can kind of see where that, whoops, I went too far, right there that it goes to negative 5, 0, right? And once left of negative 5, notice my y value ceases to exist. That indicates that I can't go below that, and I'm not going left of that. Okay? So you can write yourself an explanation here, however you want. Use the graph and trace feature. Once left of x equals negative 5, the y values cease to exist. And I'm off the page. My apologies. Okay. Example 10. Last one. Domain and range. Again. Okay. What do we talk about up above with domain? If there's a square root, what do you know? Okay, whatever's under the square root has to be positive. So that means what's under the square root here is x, right? So that means we know x has to be greater than or equal to 0 because there's a radical. Now, there's another piece to consider on this one because this problem is a fraction. Where is the other problem? We can't have a negative under the radical, so we can't use any negative x's. And Vincent?
Divide something by 0.
Yeah, we can't divide something by 0. So that means my denominator, x minus 2, cannot equal 0. Does that sound familiar? My denominator cannot equal 0, so my denominator is x minus 2. X minus 2 cannot equal 0. If I solve that, that becomes x cannot equal positive 2. So, if I attempt to write that in set notation, squiggly brace, x is a member of the reals, such that, so that's your vertical line, and we're just going to write the two pieces here, because x greater than or equal to 0, comma, x cannot equal 2. There might be another way to write that, but off the top of my head, well, there is another way to write it if we broke it up. Because we could say x has to be something between 0 and 2, not equal to, and then greater than 2. This is just fine. Range. Okay. This is outputs. Are there any outputs that aren't going to work? The last time we said we couldn't have anything negative because there was a radical, yes? There's still a radical, but what's the difference this time? It's a radical and it's going to be divided by something down here. So could we possibly get a negative? We could. My best suggestion on this one is to graph it and inspect the graph. If I graph it, whoops, second square root of x over x minus 2, Amy. Okay. If I graph this and inspect the graph, this can help me here. Okay. Range. Range is where on a graph? That is going up and down. What do you notice as you look at that graph? It looks like it's going all the way down, yes? Looks like it's going all the way up. Where's the one debate? At 0, yes. Okay, you can try trace. Notice 0, 0 appears here, so it looks like it exists at 0. Okay, you can arrow to the right, and see what happens. And it looks like it's just still going and going and going, right? It's getting closer and closer. 0 existed over here. So this should be all real numbers for your range. A way to write all reals is to just write your big fancy R that represents all reals. Okay. And how did we decide that? We looked at the graph, right? All values appeared to work. And then we also specifically checked 0. And we could check 0 by hand by putting 0 in for x and seeing what happens. Okay. Get what you need there. And that's what I was afraid of. This is a long lesson. We've got about 5 minutes.